Hello, now let's learn Pythagoras theorem. Prove that in right angled triangle the square of hypotenuse is equal to the sum of squares of remaining two sides. Okay, now let's give it solution. As per the situation, we need a right angle triangle. Let us suppose triangle ABC is right at vertex B. Let's mention this in given. In triangle ABC, angle ABC equals 90 degree. Means triangle ABC is a right angled triangle. Then what to prove? According to the statement, in right angled triangle, the square of the hypotenuse is equal to the sum of the squares of remaining two sides. What is hypotenuse? Hypotenuse is the side opposite to right angle. In triangle ABC, as angle ABC equals 90 degree, therefore seg AC is the hypotenuse. That's why AC square equals square of the hypotenuse equals sum of the squares of remaining two sides. Means AC square equals AB square plus BC square. Okay. Now to prove AC square equals AB square plus BC square, given information is not sufficient. That's why we need construction. Okay. Construction. Draw seg BD perpendicular to hypo AC. Okay. Draw seg BD perpendicular to hypo AC. Seg BD perpendicular to hypo AC. And due to that, there is a betweenness A dash D dash C. A dash D dash C. Okay. Now let's start a proof. In a triangle ABC, angle ABC equals 90 degree. Since it is given, okay, and then seg BD perpendicular hypo AC A dash D dash C. Reason for this construction. Okay, we learned that in a right angle triangle, perpendicular drawn through the vertex of right angle on hypotenuse divide the triangle in two triangles, and these triangles are similar with original triangle and with each other by similarity in right angle triangle. Now let's apply that similarity in a right angle triangle. According to that, therefore triangle ABC is similar with triangle ADB, and further that triangle is similar with triangle BDC. Okay, let's mention here. Therefore triangle ABC similar triangle ADB similar triangle BDC. Since similarity in right angled triangle. Okay. Now let's select pairs of triangles such that we will get AB square as well as BC square. and then later on we will add AB square and BC square to get AC square. Let's consider first pair of triangles. Therefore, triangle ABC similar triangle ADB. Okay, and therefore let's write CS ST, corresponding sides of similar triangles. Means here, therefore AB upon AD equals BC upon DB equals AC upon AB. Now let's select first ratio and third ratio. Therefore it will be AB upon AD equals AC upon AB. And now by cross multiplication, AB into AB gives us AB square equals AC into AD, AC into AD. Let's call it as equation first. Similarly, triangle ABC similar with triangle BDC. Let's write here triangle ABC similar triangle BDC. Okay, and therefore if two triangles are similar, then their corresponding sides are in proportion. Means here AB upon BD equals BC upon DC equals AC upon BC. Now select second and third ratio, and therefore it will give us BC upon DC equals AC upon BC. And now by cross multiplication, BC into BC gives us BC square equals AC into DC, equation second. And therefore from 1 and 2, AB square, equation 1 gives us AB square, equation 2 gives us BC square. AB square plus BC square equals, right side of equation first is AC into AD plus right side of second equation is AC into DC. Okay, now at the right side you may note AC we may take out common, and therefore in bracket there will be AD plus DC. But AD plus DC is what? AD plus DC is AC. Let's mention here into AC. Since what? A dash D dash C. And therefore we can write AB square plus BC square equals AC square, and therefore AC square equals AB square plus BC square. Hence the proof. Now let's learn converse of Pythagoras theorem. Prove that if in a triangle square of one side is equal to the sum of squares of remaining two sides, then that triangle is a right angled triangle. Okay. Now in a solution of this statement, we need such a triangle that square of one side is equal sum of the squares of remaining sides. Already we know that it is possible only in a case of a right angle triangle. We are going to draw a diagram of right angle triangle, but not going to show its angle having measure 90 degree, because we are interested in, we are going to prove it is a right angle triangle. Let us suppose in triangle ABC, let's mention given E in triangle ABC, square of one side means AC square equals AB square plus BC square. Then what to prove? In such a case, the triangle is right angled triangle. Okay. Now we know that obviously an angle opposite to AC will have measure 90 degree, because AC will be the hypotenuse. Because we learned in a right angle triangle, hypotenuse is the longest side. Side opposite to right angle is the hypotenuse, and angle opposite to hypotenuse is a right angle. Okay, that's why to prove angle ABC equals 90 degree, that is triangle ABC is a right angled triangle. Okay. Now let's prove this thing. As we know that it is only possible in a case of a right angle triangle. Let's draw such a triangle that it will be right angle. Okay, and that we are going to mention it in construction. Construction. Draw triangle PQR such that, such that its side PQ equals side AB, side QR equals side BC, and angle PQR having measure 90 degree. Okay, let's draw such a triangle in case in which, yes, what is the length of AB? That much be the length of PQ. Okay, let us suppose it is segment PQ. And what is the length of BC? That much length of QR. What is the length of BC? That much length of QR. Okay. Let's show by identical mark AB equals PQ, BC equals QR, and angle PQR equals 90 degree. Okay. Now let's start a proof. We don't know whether triangle ABC is right angle or not, but triangle PQR is definitely right angle triangle, because in a construction we have mentioned angle PQR equals 90 degree. Let's start with that triangle PQR. In a triangle PQR, angle PQR equals 90 degrees, since it is our construction, isn't? Since it is construction. And therefore we may apply Pythagoras theorem. According to Pythagoras theorem, we can write PR square equals PQ square plus QR square. PR square equals PQ square plus QR square by Pythagoras theorem. Okay, but our construction tells us PQ equals AB and QR equals BC. Let's put PQ as AB and QR as BC, means it will be AB square plus BC square. Let's call it as number 1, since it is our construction. By construction, what we have replaced? We replaced PQ by AB and QR by BC. But according to given, AB square plus BC square is what? AC square. Here we are getting PR square equals AB square plus BC square, and therefore PR square equals, but AB square plus BC square is AC square, means PR square equals AC square. Since what? AC square equals AB square plus BC square, since it was given. Okay. And therefore, if we take its root, then we are get PR equals AC. Let's call it as equation second. Okay. And therefore, in a triangle ABC and a triangle PQR, yes, we can say AB is congruent with PQ, BC is congruent with QR, since it is our construction. Okay. And third side, that is AC. AC is congruent with PR from second, and therefore triangle ABC is congruent with triangle PQR by yes test. And we know that if two triangles are congruent, then their corresponding angles are congruent and corresponding sides are congruent. We are only interested with angle ABC and its corresponding angle PQR because we are interested to prove angle ABC have measured 90 degree. Okay. Therefore, let's mention here angle ABC congruent angle PQR, since corresponding angles of congruent triangle, and therefore angle ABC equals 90 degree. Since angle PQR have measured 90 degree, and therefore triangle ABC is a right angled triangle. Okay, it is right angled triangle. Hence the